we're going to do a quick review first of just some basic terminology that we use with the different functions that we have in math: add, subtract, multiply, divide, equals, things like that. We've got a big old list for you at the top here of some different words that can be used for each of those. And then just with a couple of notes right below that talk about when we get into things like subtract from, less than, take away from, that it kind of switches the order that we would do things. Because a lot of time we just do it like we do. We read books left to right. We read sentences like this left to right, but we don't necessarily write them left to right every time. So as straightforward as some things are, 5 more than a number n. Now again, you get into reflexive properties here, I can get away with writing it either way. Because if you think about it, with a number, 2 plus 5 and 5 plus 2 is the same thing. So order isn't as big of a deal when we're talking with addition and multiplication. It does matter, though, on the other two. So if you get into something like a number n divided by 5, I don't care if you do it like this. I don't care if you do it like this. But you can't do 5 divided by n. That's not the same thing. The values would be different. So you do have to be a little bit more cautious when you get into divide and subtract. Or in this one, 5 less than a number n, is that 5 minus n or n minus 5?
N minus 5.
N minus 5, because it's 5 less. I want to take 5 away, and if I want to take the 5 away, that's where the minus needs to be. If I wrote 5 minus n, I'd be taking the n away, and I don't want to do that. So let's see. Let's bounce around a little bit. What would number 6 look like? Yes, sir.
4n plus 3.
Okay. 4 times the number n plus 3. Okay, that's pretty straightforward. Let's see. Ooh, what about 10? Yes, ma'am.
5n minus 3.
All right, nicely done. Because we got 5 times the number, but again, there's that less than that's a little bit screwy. And again, if I want to take the 3 away, that's going to need to be at the end. All right, now we're going to start seeing what we're made of here. What about 11?
Times x plus 5 in parentheses.
Nice. I was going to say, I was waiting to see if the parentheses were coming. If I want the product of that 8 and that sum, or if it said difference or quotient or anything, I've got to have the parentheses there to say I want these grouped together. Because if I didn't have the parentheses here, then it would be the product of 8 and x. I'm adding 5 to it, and that's not at all what I want to do. So whenever I see that product, I want to make sure that I get that set. Now let's see, so then what's 12 going to look like? Okay. So 7 more than the product of 6 and y. Don't need any parentheses this time. Actually, don't want them. They would make things worse. So I have to make a little bit of a change there. Okay, let's see. I'm running out of things that might mess with you. What about 14?
2 times 9 plus x in parentheses.
All right. Twice the sum of 9 plus x. Because sometimes people see twice and they want to square something. That's a little different. So nice catch there that it's 2 times. And again, a product and a sum, we want to make sure that we get our quantity into parentheses. And finally, 16 before we start putting them into words. 1/2 the square of x. He's going to keep on a roll. Go for it.
X squared over 2.
Okay. X squared over 2. If some of you were thinking, well, I thought it said a half, can I do this? Absolutely. Okay. Quite a few of these, there's some flexibility. Not always, but sometimes. And again, just getting yourself back used to some of the language is going to help out. Now, when we talk down at the bottom about verbal sentences, again, there's several ways to write each of these. So, for instance, on 17, somebody may say the product of 3 and x minus 5. Or you may say 5 less than the product of 3 and x. Or you may say 5 less than 3 times x. There's a whole heap and lot of different ways for you to be able to do that. So don't get stuck into, oh, I'm not sure if, because you probably are going to be okay with that anyway. But as you start getting into some of the ones after that, now it starts to get a little more interesting. So let's see here. 18. Anybody care to take a shot with 18?
2 times the sum of a number n and 4.
Oh, all right. So 2 times the sum of a number n and 4. Nicely done. All right, one more. Which one do we want to tackle? Let's try out 19 here. 19. Yes, sir.
1/2 of m plus 7 equals total of 10.
Okay. 1/2 of m plus 7 equals a, or the total of 10. So much flexibility in doing these. Okay. And again, this exercise is more just to get you used to the language. So when you do come upon something in a standardized test and they throw a strange word in there or a different way of looking at it, it doesn't throw you off at all. Okay? So now, kind of getting that flowing back in, we're going to flip over here. And we're going to take what we've been talking about with equations, and we're going to expand this a little bit. Because now not only are we going to solve for variables, we are going to solve for multiple variables in a problem. So for instance, and excuse me for having these so tight, these are supposed to say like 4 something. It doesn't mean like plug 8 in for y. That's not what we're getting to here yet. So for instance here, 7x minus 3y equals 8, solve for y. Where will this come in handy? Graph and lines, slope-intercept form, okay? So if I want to solve for y, I always like to make comparisons of things. It's much easier to give bad news to someone far away via text, email, or something than it is if they're right in your face. So I say the same thing for a variable. Y is going to say adios to everybody on its side of the equation except itself. Well, the negative 3 is kind of close, so we're not going to tell it to go away right away. How do I get the 7x out of there? Subtract it. So, and before someone asks, they might say, well, can I put 8 minus 7x? You could, but again, I like to always think ahead. If I'm going to use this as a skill that I need to solve for y and in drawing a line, I want to have it in y equals mx plus b. So I naturally just put the x first, but you could have it the other way. And then what would be my last step to get y alone?
Divided by -3.
Okay. Now again, you have a choice. If you divide each term by the negative 3 right away, oops, let me get back on the screen here. You'd have negative 7 divided by negative 3, it'd be positive. And 8 divided by negative 3 would be negative. So if you wrote it, it would look more like slope-intercept form. It would look like this. But let's say you were doing it because you were going to just plug a number in for y. You also could write it okay? Those are equivalent. So there may be a time that you look over at the board and you've written your answer down this way and I have it this way and you're like, wait a minute. I think I got my answer wrong. Before you erase it, look and see. Okay, wait a minute. Well, negative divided by negative is positive. Positive divided by negative is, oh, they're the same thing. So watch for those things, especially when you're doing them in ones like this. It can make it a little bit tricky on you. Okay? And it's not just for math class stuff. Here's one you should see in business if you have any business classes all the time, the interest formula. Interest equals principal times rate times time. This is also going to be the easiest one to solve. I want to solve for t. One step and we're done. What do I need to do? Yeah, since I'm multiplying t by p and r, I need to divide. So I will divide both sides by p and r, which will cancel those out and just leave me with t. It's interest divided by principal times rate. So if I want to know how much time it's going to take for something, for my money to grow to a certain amount, I can do that. Okay, it gives me the flexibility that I need to be able to accomplish that. So let's see. Sometimes, yeah, we might want to solve for x as well. It's kind of similar to what we did here in A. Again, want to get x alone, what should I do first? Right, I'd want to go ahead and I want to add the 9y. And I'm going to set it up similar like I did when we were doing slope-intercept form. And then again, divide by 11, you have a choice. When I divide by the 11, if I just choose to divide my whole fraction by 11, I can. If you want it more into this form, and you write 9/11ths y minus 4/11ths, that's fine. They're both correct. So again, don't sit there and kind of run over it and go, I don't know which, because they're both right. Okay? But now I got to throw the curveball in. Because one thing that you'll learn about when you're solving for a variable, you're not allowed to have the variable be part of your solution. Like for instance here, I couldn't just subtract xy to the other side, divide by -1 and say, woo! It doesn't work that way. So what I tell people is, okay, since I can't have y be part of my answer, but there's two y's here, I got to get this down to one y somehow. So I always use a different example here at the start, and then all of a sudden it kind of goes, oh, the aha moment comes. So let me change up on you here for just a second. If I told you to take out the greatest common factor that those two had, we were going to factor this for a minute. What's the largest number that divides into 4 and 12? 4. So 4 times what gets me to 4x? Yeah, some of you are ahead of me. Okay, and then right. Basically what you're doing is you're doing the distributive property backwards. You're factoring because you have something they have in common that you could pull out. So now, let me get rid of this. What do these two terms have in common? Y. So I'm going to pull a y out. Y times what gets me to xy? X. And y times what gets me to negative y? Negative 1. All of a sudden now there's only one y there. Good for us because we needed it that way. So now to solve for y, it's just one step. I need to divide by this quantity of x minus 1. And I'm set. Do I have to have the parentheses? No. I just like always doing that with my quantities just to be sure. Okay. So if you ever see a variable that you're solving for and there are multiples of that same variable, look to do some quick factoring to pull out a common factor. It'll make life easier on you. Okay. And that's probably the hardest part of anything we're doing here today. Because now, calculating the value of a variable, we're only going to do the first one on this one because it is as easy as it looks. They're actually going to give me a value this time for x. Okay, great. I will plug that value in for x, and I'll solve it for y. So I'm going to minus my 3 over, and divide by 2, Woohoo! I'll take that any day of the week. So it's just a substitute and a quick solve. So that's going to make those go a lot better. Then, of course, and I'm not going to lose them this time, no, story problems. Okay. Writing equations with more than one variable. Oh boy, we even get to write them now. We're organizing a benefit concert. We're planning on having 2 types of tickets, adult and child. Write the equation with more than one variable that represents the revenue from the concert. Okay, let's put it in English. We're going to sell some adult tickets. We're going to sell some child tickets. And those together, so I have to plus, are going to make me some revenue. They're going to make me some bucks. Now, since they're asking me to use variables, I can. I'll just use the first letter of every one of these. So my big, great equation is going to be A plus C equals R. My adult tickets and my child tickets equal how much revenue I'm going to take in. And this is what arenas actually do. They look at how much it costs to bring whatever artist is in, and then they look at how many tickets am I going to sell, how much can I get for a ticket, how much profit does that end up making. This is all the stuff that goes into that. So math actually comes in a little handy. So for our concert example 3, our goal is to sell $25,000 in tickets. There's my revenue. So we want to equal 25,000. Excuse me. You plan to charge $25.25 per adult and expect to sell 800 adult tickets. Whenever we're talking about adult or children here, we're talking about the number you sold times the price that you are going to charge. So how many tickets am I selling? How much am I getting per ticket? And that's going to be true for both of these. Now the nice thing about the adult tickets is not only do they tell us the price, they also tell us how many. Cool. So 800 at $25.25. So then we're like, the variable must be coming. You need to determine what to charge for child tickets. Okay, so that's going to be our variable. How much should you charge per child if you expect to sell 200 child tickets? Okay, so I'm going to sell 200, but I have no idea how much I should charge for them. Well, this shouldn't be too hard for us to figure out because we have all the other information. So if I multiply these two guys together, this fairly quickly should get me to how much that ticket needs to cost. Because now I know I'm going to get $20,200 worth of revenue from my adults. So I'll subtract that. Leaves me with another $4,800 I need. And I only got 200 child tickets that I'm selling. So if I divide by 200, looks like the child tickets need to be about $24 a piece. Now, I could do that exact same process for all 3 of these, but I am smarter than that today. Yes, I have been in class for 3 days, so I know better. When I ask for 300 child tickets, my adult revenues don't change. What I'm selling in total doesn't change. The only thing that's changing is this number in front of C. So why do all this again? I'm just going to change the number in front of C and keep everything else the same. Because I like saving time. I'll divide by 300. Looks like it's going to be 16 bucks a ticket. As we can get more common sense going along with this, it not only saves us time, but it saves us less places to make errors. 400 tickets. I might be able to shorten this up more. That makes sense. Because if when I had 200 tickets it was 24, I sell twice as many tickets, it only cost me half as much. Hot dang. So, again, it's not wrong if you do all this for all of them, but again, don't make life complicated. Just don't do it. Don't do it. And finally, the formula for the perimeter of a rectangle, we're back to this again, is 2L plus 2W. Solve for W. isolate the term that you want to solve for first. How do we dump the 2L?
Divide by 2. Or have P divided by 2.
You're slightly ahead. Right now I'm adding 2L to 2W. What's the opposite? Subtract. So we're going to subtract 2L. That isolates my W term, but now to isolate W itself, I'm going to go ahead and divide by 2. Now again, we have options on how this can look. I can leave it as one big fraction, perfectly acceptable. Or if some of you are sticklers and you want it in the fractions, okay, I'd have 1/2 P. Negative 2 divided by 2 is negative 1. Those are both the same thing. They may not look like the same thing, but they are. So just to have you prepared and ready for that. Now, at least we don't have this stuff in multiple places this time. And I'm not even going to be a jerk about this. I'm going to back this up because it's Friday and I try to be nice. So let me move this. All right, here's what you're up to. This is the homework, but they're like, oh, fine. But we aren't going to do all of these. On this worksheet, you're only doing the evens as far as the problems on here. So there's 11 problems instead of 22. But I do need you to work on the problems on the book part at the bottom, because that's going to get us into some of this story problem stuff, and we need to deal with it. Okay? So on the more 1.3, where it says 6A here, evens here, book stuff at the bottom, and we will chat about that Monday along with how this whole homework check thing is going to work a little later next week. Any issues? Any issues?